Okay, let's take a look at how to graph our other four trig functions: secant, cosecant, tangent, and cotangent. If we want to graph these, certain elements of how we graph sine and cosine will still very much apply, but of course there will be several things that are notably different. The first of those things, amplitude is a term that we can apply to sine and cosine. We cannot apply this to our other functions. Rather than amplitude, we will have a vertical stretch or compression. So we start off with this first example. We have a cosecant function. Now you can analyze this as you go, you can analyze this and then set up your axes. Either is possible. I'm going to go ahead and begin by analyzing. This 3 in front indicates a vertical stretch. There's no negative there, meaning there's no reflection in the x-axis, but I can see that this +1 means that I have a vertical shift up 1 unit. Make sure you're indicating direction. To find period, I always take the function's natural period and divide it by b, the coefficient of x on the argument inside your trig function. For secant and cosecant, the natural period, just like sine and cosine, is 2 pi. So if I take 2 pi and divide it by here, b is 1/3. 2 pi divided by 1/3 is 6 pi, because dividing by 1/3 is the same as multiplying by 3. Now if I want to find the phase shift, I can always find a phase shift by setting whatever is inside my trig function to 0. This will always work. If I set this equal to 0 and solve, I'll find the phase shift. A more useful method that we have been using is our bookend method. So secant and cosecant, I will still use the bookends of 0 to 2 pi, just like I did for sine and cosine. So if I set this up, and then I subtract 3 pi over 2 from both sides to solve, or from all three parts, because I am subtracting it from the middle as well. 2 pi is, of course, 4 pi over 2, so if I subtract 3, I'm left with pi over 2. And then I multiply by 3. If I do that, I get negative 9 pi over 2, x, and 3 pi over 2. Now, my phase shift, as I said, is found by setting the argument of your function to 0 and solving, which means right here, this number on the left tells me my phase shift. My phase shift is 9 pi over 2. Since it's negative, it will be to the left. Okay. Asymptotes, range, I will find those once I have my graph. Now if I want to graph this, I'm going to start off setting it up much the same way as I would for a sine or cosine. I shift up 1 and I have a vertical stretch by 3. Here's 1. My stretch is 3. That means I need to go 3 units above that and 3 units below. So that takes me down to -2 and up to 4. Along my x-axis, I know I always cut my period into fourths. So if I take 6 pi and divide it by 4, that tells me I need to count by 3 pi over 2. In the positive direction, I'll count 3 pi over 2. And I would have after that 3 pi. But actually, as I look at this down here, what my bookend methods tell me is that I'm going to graph between negative 9 pi over 2 and 3 pi over 2. I really don't even need this 3 pi. So let's worry about counting in the negative direction. I go from 0, try and space these out approximately equally, negative 3 pi over 2, negative 6 pi over 2, it's negative 3 pi, and then I have negative 9 pi over 2. That's what I know I'm doing. I'm graphing between negative 9 pi over 2 and 3 pi over 2. All right. My axes are prepped. So the question now becomes, how do you actually graph a secant or cosecant? And what you're going to do is think about the underlying reciprocal function. So cosecant is actually the reciprocal of sine. So I'm going to think about the function that has all this same stuff, except instead of a cosecant, it's a sine. So I want to think about this. All right. Well, for my sine, I know I would put a dashed line for my baseline right through 1. I know that sine starts in the middle. So I'll come in over here at negative 9 pi over 2. I'm going to start in the middle. Sine would normally go up. There's no reflection, so I will still go up to 4. Come back to the middle. Go down to the bottom. Back to the middle. Middle, high, middle, low, middle. Now I'm going to put a dashed curve through this because here's the deal. These points don't actually represent my cosecant, which is what I'm trying to graph. They represent my sine function. So what I want to know is how to take these points, the points of this sine curve, and create a cosecant function. Well, secants, cosecants, for that matter tangents and cotangents, all have asymptotes. I can find these based on where this curve hits this center dashed line. So, right here at negative 9 pi over 2, this sine right here, just the sine, would equal 0, which means this cosecant over here would be undefined. So right here, I have an asymptote. Right here at negative 3 pi over 2, again I hit the baseline, again I have an asymptote. At 3 pi over 2, again I hit the baseline, again I have an asymptote. So I have the asymptotes now. I can see where my asymptotes are. To create the actual cosecant graph, I'm going to look at the two remaining points. Since cosecant is the reciprocal of sine, it will end up sharing these 2 points with the sine graph. It will reach 4, it will reach negative 2 down here. But since it is the reciprocal, where my sine is going down, going back towards that baseline, my cosecant will actually go up towards infinity. So what I see is this upward facing curve. Kind of looks like a parabola, but it's not a parabola. Squeezed between these two asymptotes, I see this upward facing curve that goes through that point on the top of my sine curve. Down here, I will go down. Again, I'll have the reciprocals. So I go down. Squeeze it between the asymptotes. And those curves that I last drew, those curves in purple right there, are my cosecant function. Now, the last bit of analysis we have over here are our asymptotes and our range. We don't ask for the domain in general because to answer the domain in general, I'd have to describe all of the asymptotes. This function continues. I'd see another curve up here and then another one down low. Here I see another one down low and then another one up high. I do have an infinite number of asymptotes. To give the whole domain, I'd have to describe all those asymptotes. So we're not going to worry about that right now. The asymptotes that we do see, we can see x equals negative 9 pi over 2 is one asymptote. X equals negative 3 pi over 2 is another asymptote. And the last asymptote we graphed was x equals positive 3 pi over 2. Now how about our range? Well, from my range, I can see while my sine curve was in between negative 2 and 4, my cosecant curve includes negative 2, includes 4, but goes up and down from those points. My range, then, goes from negative infinity up to negative 2, which it reaches. So I put a bracket. Union, to come up here, I go from 4 up towards positive infinity. And that is the range of my cosecant function. Again, if I wanted to describe the domain in general, that would be tough because I have to describe where all of the asymptotes are. But the range I can see a bit more easily. I go down from negative infinity up to this point, and then from this point up towards positive infinity. And that's my cosecant graph. If I want to graph a secant, let's try a secant now. So this is written in sort of a funky manner. We know we're going to think about the cosine, we're going to think about its reciprocal when we try and graph this, so I can worry about that. I'm going to rewrite it as a cosine and put it in an order that we would prefer. All right, if I want to analyze this, the first thing I see is it's negative 1/2 the secant. That negative means that there is a reflection in the x-axis. We'll see how that affects our graph once we're working through it. The fact that there's a 1/2, well, 1/2 is less than 1. So rather than a vertical stretch to this secant, I have a vertical compression by 1/2. The -2 indicates that I have a vertical shift down 2. To find my period, well, notice here I have the secant of 4 times x minus 3 pi over 8. All of that is inside my trig function. All of that is the argument of that secant. So I have to take the 4 and divide that into 2 pi. 2 pi divided by 4 is pi over 2. Now again, to find the phase shift, I'm always able to take whatever the argument is here, set it equal to 0, and solve. But I'm also very strongly encouraged to use my bookend method. Secant and cosecant, just like sine and cosine, my bookends will be 0 and 2 pi. Now be very careful when you do this. Of course, we need to use x minus 3 pi over 8. But if I don't use that 4 there as well, my bookends will not be correct. Make sure to use the whole argument when you're doing this. You're welcome to distribute. It'll work out just fine if you do that. But it's also fairly simple to divide everything by 4 as you begin. If I do that, I will have 0 is less than or equal to x minus 3 pi over 8, which is less than or equal to pi over 2. From there, I want to add 3 pi over 8 to all 3 parts. So if I do that, well, pi over 2, essentially 1/2 of a pi, well, 1/2 is 4/8. So if I add 3/8, I will get 7/8, so 7 pi over 8. So again, this tells me when I graph, my graph will be between 3 pi over 8 and 7 pi over 8. This also tells me, since this was 0 right here, my phase shift is 3 pi over 8 to the right. Make sure to include that direction with your phase shift, just as with your vertical shift. It needs a direction. Okay, so now we want to go ahead and set up our axes. My vertical shift was down 2 units. So here's -2. Since I have a compression by 1/2, I only need to go up and down a little from there. I'm going to see a fairly tight curve here when I graph this. Okay. On my x-axis, I'm going to count by 1/4 of my period. So pi over 2 divided by 4, that gives me pi over 8. So if I count pi over 8, 2 pi over 8 simplifies to pi over 4. You can write these down up top and simplify as you work. 3 pi over 8, 4 pi over 8 is pi over 2, 5 pi over 8 does not simplify, 6 pi over 8 is 3 pi over 4, and then finally I get to 7 pi over 8, which is where I should stop based on my bookends. Okay, so here's the deal. To graph the secant, I'm first thinking about graphing this cosine. I put this dashed line in. I'm going between 3 pi over 8 and 7 pi over 8. Now the cosine normally starts at the top of its range. Normally I'd start at the top. Since there is a reflection, I will instead start at the bottom and then go to the middle, up high, back to the middle, back down low. Again, I'm putting a dashed line through this, dashed curve, because that is the cosine. What I actually wish to graph is the secant. To turn this into a secant, just as I did in the previous example, anywhere that I hit this baseline, I need an asymptote. So I can see I have an asymptote at x equals pi over 2 and at x equals 3 pi over 4. To graph the secant, I'll use these other key points. From here I will go down, get close to the asymptote. In the middle I'm going up and squeezing in between these asymptotes. Make sure you're drawing it close to them. Over here I will go down. And that is my secant graph. Now again, as I did this, notice I established my scale on the x-axis. I counted by pi over 8, even though I didn't need to start graphing until 3 pi over 8. My asymptotes are x equals pi over 2 and x equals 3 pi over 4. And again, I would see more if I extended this. The next one, I guess, would be at x equals pi over 4. The range, well, I can see I'm going down to negative infinity. From negative infinity, I come up to negative 2.5, negative 2.5 or negative 5 halves, bracket, union. Up here, this is negative 1.5 or negative 3 halves. And from there I go up to infinity. So that is my secant curve. All right, let's take a moment. Let's go ahead and look at a couple of tangent problems, a tangent and a cotangent. All right, now again, some of the principles that we used for graphing sine and cosine will still be useful here. But tangent and cotangent have some more important differences compared to sine and cosine. Once again, sine and cosine are the only ones with amplitude. For tangent and cotangent, I just have a vertical stretch or compression. In this case, since I just see 2 plus the tangent, that means there is no stretch or compression. It's just the tangent. This 2 right here indicates that I am shifting up 2 units. Now, to find the period of a tangent function or a cotangent function, tangent and cotangent naturally do not have a period of 2 pi. They have a period of only pi. So again, I will take the natural period, pi, and divide it by b. So I take pi and divide it by 3, so that will just be my period, pi over 3. For the phase shift, again, I want to emphasize the phase shift is always found by setting whatever is in that function, in those parentheses, equal to 0 and solving. If I do that, I can find the phase shift pretty directly. But if I start thinking about the bookends, which we do want to, something a bit strange happens. For my sine and my cosine, my secant, my cosecant, it makes sense to look at those going from 0 to 2 pi. Tangent's period is only pi, but I want to consider what it looks like between its asymptotes. So when I picture tangent naturally, I picture it between negative pi over 2 and pi over 2. Tangent will naturally go up because I'll go from having negative values of tangent over here to positive values of tangent over here. And this will be my basic sketch of tangent. This will be the image I keep in my brain. Now this is really important for a number of reasons. 1, the period is only pi. 2, what are my bookends? rather than 0 to 2 pi, my bookends will end up being negative pi over 2 to pi over 2. And the other thing that is strange about this, since my phase shift comes from setting whatever is inside here, the argument of my trig function, to 0, well, since I'm not using 0 here, I'm not going to get the phase shift from doing my bookends. My phase shift will be halfway between my bookends. The phase shift is in the middle of your bookends. So we'll see how that plays out as we graph this. Let's go ahead and continue with these bookends, because I know I want to graph the tangent between whatever values of x I need to make this happen. So I add pi to all three parts. Negative pi over 2 plus pi will give me pi over 2. Pi over 2 plus pi gives me 3 pi over 2. And now I want to divide by 3. So dividing by 3, multiplying by 1/3, pi over 2 becomes pi over 6. 3 pi over 2 would be 3 pi over 6, or rather pi over 2. So I know that I'm going to graph between pi over 6 and pi over 2. Okay. When I go to label my axes, my vertical shift is up 2 units, and I can see what my period is. I'm always going to divide my period by 4, so pi over 3 becomes pi over 12. I want to count by pi over 12. So here's pi over 12. 2 pi over 12 is pi over 6. 3 pi over 12, 3 over 12 simplifies to 1/4. 4 pi over 12 is pi over 3. 5 pi over 12 does not simplify. And 6 pi over 12 is pi over 2. And I can see I got my bookends along the way. There's pi over 6, there's pi over 2. Okay. So my x-axis is set up. How do I set up my y-axis? Well, I can see I have a vertical shift up 2 units. Just as with a sine or cosine, I start from that vertical shift, and I need to worry about going up and down by whatever my vertical stretch is. Since there is no vertical stretch, that means I'm only going up and down 1 unit. So I'll go up to 3, I'll go down to 1. And again, I can put a little dashed line across here to indicate the center of my graph. Now this is going to be similar in some ways, but again, as I said, different in some very important ways. My bookends right here indicate my asymptotes. So I'm going to draw asymptotes in at x equals pi over 6 and x equals pi over 2. My tangent is going to go generally up unless there's a reflection. This does not have a reflection, so I know I'm going generally up through this interval. Right in the middle, I start in the middle. And on either side, I go up and down by whatever stretch or compression I have out there. Since there's just a 1, I will go up and down 1. Then as best as I can, I want to try and put a smooth curve through those points that gets close to those asymptotes. So let me go ahead and do that. That is my tangent function, that function in green. So, several interesting things happening there. Again, the period is only pi. I only have 3 key points in these asymptotes on the end. Now, when I do this, I can see my bookends gave me my asymptotes. X equals pi over 6, and x equals pi over 2. My phase shift, as I said, is in the middle of my asymptotes. Well, if we've done this well and our numbers work out nicely, I can see what's right in the middle. pi over 3. So my phase shift is pi over 3 to the right, which again, as I've been trying to emphasize, we could also just take 3x minus pi equals 0 and solve this. 3x equals pi means x equals pi over 3, and there's my phase shift. And I have my tangent graph. So again, if we wanted to generally describe the domain, we would need to describe all of the asymptotes because there are an infinite number. This continues and continues and continues. But the range I can describe very easily. I can see over here I will get to very, very small values of y, and I've got everything in between, and I go up to very large values of y. So my range, regardless of my transformations for any tangent or cotangent, will end up being all real numbers, or in interval notation, negative infinity to infinity. Now again, I know that's tricky. I know there's several interesting things that are going on here, several little tweaks that we have to make. The period is naturally pi. We want to graph between the asymptotes, which means we get bookends of negative pi over 2 and pi over 2. And we have to do a bit more work to figure out our phase shift because it's halfway in between those asymptotes. But once I get all that figured out, graphing a tangent is really just as easy as graphing any of these other functions. Let's go ahead and do one last example. Let's look at a cotangent. All right. So I can worry about all of my analysis. I can see there's a reflection in the x-axis. I can see I have vertically stretched by 3. I can figure out that my period is pi divided by 4. For my phase shift, well, I notice here there are no parentheses, which means this is 3 times the cotangent of 4x minus 3. There's no phase shift. But what there is, and I forgot to write it here, is a vertical shift down 3. This right here is a reflection in the x-axis, a stretch by 3, and this minus 3 means we are shifting down 3 units. All right. Cotangent and tangent, as I said, naturally the period is pi. Let's remind ourselves what our basic cotangent graph looks like, our parent cotangent. Well, for our parent cotangent, we go from 0 to pi over 2 halfway in the middle, pi over 4, 3 pi over 4 are other key points. I have asymptotes at at x equals pi and at x equals 0. Where our tangent naturally went up, our cotangent will naturally go down. So we have a very general sense of what the cotangent would look like. Now let's go back to labeling our axes. I can see I've shifted down 3 units. I have a vertical stretch by 3, negative 3, negative 6. So long as I'm just establishing a scale, I could really just count by 3's right here because I only need to go between 0 and negative 3 and negative 6 on the y-axis. If my period is pi over 4, that means I need to count by my period over 4, which would be pi over 16. So if I count pi over 16, 2 pi over 16 is pi over 8. 3 pi over 16 does not simplify. 4 pi over 16 is pi over 4. I apologize. I realize I'm sitting right here, and what I didn't do was do my bookends. My bookends for my cotangent are from 0 to pi. That was why I drew this. So if I go from 0 to pi, well, there's no phase shift, so this ends up being a very quick bit of math. I just divide by 4 and go from 0 to pi over 4. So I've got my x-axis set up. My y-axis, again, I shifted down 3 units. I need to go up and down by whatever that stretch is. I'll plot my asymptotes. They're at 0 and pi over 4. That's what my bookends tell me. So when I go to do this, tangent, cotangent, in the middle, I'm right in the middle. I know my cotangent, excuse me, sorry, late in the day I'm making some errors. Not here. In the middle, I need to be right in the middle, meaning I need to be right down at -3. I forgot to draw this line. All right. So, I messed that up a little bit. I'm sorry. I've vertically shifted down 3, so I draw in this line. Tangent and cotangent, in the middle, I will be exactly in the middle. Now, normally a cotangent will go down. Since I do have this reflection, I know I need to go up. So I will go down by this vertical stretch over here, so down 3 and up 3. And then as best as I can, I want to put a smooth curve through these points. That gets closer and closer to those asymptotes. I can see my asymptotes are x equals 0 and x equals pi over 4. My range, as with any tangent or cotangent, is -∞ to infinity.